Good morning. My name is Imam Platon. Understanding material science. What is material in relation to fashion and textiles? What are the main categories of material in fashion and textiles? What are the material science in relation to fashion and textiles? And how can material science work or function in the real world in fashion and textiles? And with an examples. So these are the topics we are going to learn about material science and what material is and what it involves and how it relates to it. Material and its main categories. Material in fashion and textiles refers to the raw substance or fabric used to construct a garment or other products. So there are main categories of material in fashion and textiles. You have natural fibers, you have synthetic fibers, you have generated fibers or semi-synthetic fibers, then you have the blend. Under the natural fibers, we have the wool, the cotton, the silk, and the jute. That's from the plants and animals, plants or animals. Then you have synthetic fibers, that's the polyester, the nylon, the acrylic, the spandex, that's the man-made from chemicals or polymers. Then we have the regenerated or semi-synthetic fibers. That's the rayon, visco, modal. That's what the natural source or chemically processed. Then we have the blend, which is the combination like cotton polyester with balanced properties. What do you mean by material science? So material science is the engineering of matter of a molecular and structural levels to give a fabric a specific measurable properties beyond looking good. So it detects how a garment reacts to the heat, water, electricity, and force. So material science is the study of properties and how it manipulates the structure to get the desired performance. So an example is the sportswear. So material culture helps in constructing a sportswear. So let's say if you have a product like one of these jerseys, so the jersey absorbs the heat, water, and the forces comes with it. It stretches. So without the elasticity of it, most of the garments will be you may have a distraction in it. So material science is really important in our everyday lives. So in fashion and textiles, material culture is really necessary because without it, we will not be able to get what we want. So in textiles and fashion, it's not only about making fabric pretty, it's about engineering fabrics, yarns, and fibers for a specific function. Example, comfort, durability, sustainability, and smart tech. So an example is a geotex, that's the waterproof and breathable. We have the spandex, that's the stretch. Then we have the bamboo charcoal, that's the odor control. So when you sweat, it absorbs the odor in it. Then we have the phase change material, that's the temperature regulation. So your body becomes hot or cold, so the fabric absorbs it. Then you have the biofabrics, that's lab grown leather or mushroom leather. To learn material science is really important. So how does material science works in real world in fashion and textiles? So we have performance and thermodynamics, that's the active word. Then we have the molecular geometry, that's the stretching and recovery. Example is the lycra or the spandex or the elasticity. Then we have the bioengineering and sustainability. That's the lab grown. Example is the panatex. Then the structure, then you have the structural rigidity or the sculptural fashion. Example is the neo Rene in haute couture. So I'm going to explain and give an examples on how this thing works in material science that works in the real life. So we are going to go just just topic by topic, subtopic by subtopic. So the next thing I'm going to do is the performance and thermodynamics. So example, that's a geotext. So the pores in this in creating one of these letting sweat wear escapes. So an active wear is really important. So one example is the phase changing material, that's the hard cast. So when your skin heats up, the wax melts, absorbs the thermal energy, cool, that means the cooling you. Then when you cool down, the wax solidifies, releasing the heat back, warming you. So it actually baffles the temperature winds. So that's the function of the geotext. Geotext, that's the Teflon. It's into micro porous film. So these water droplets that you have, your sweat that you have, so it absorbs them. So the sweat cannot really, it turns into a what? A water vapor molecule. So that's the geotext, what it means. Then now we go to molecular geometry, that's the stretch and recovery. For example, lycra, that's the spandex. So under the science, that's the material science, the engineering the backbone of polymer chains to act like a coil spring. Example, the lycra into bracket, the spandex or the elastin. So it consists of hard rigid sediment that bond together, providing the structure segment, and soft, which also makes when you are running or when a sportswear, you'll be able to stretch to the maximum that you have, because if the molecular geometry or the stretch recovery doesn't, you don't have the material science that helps in making garments really stretchable, you'll be having problem with it. So material science is really helpful in getting or producing a product that's good for your body. So when it stretches, the soft sediment cools, then releases hard sediment, pulling back to its original shape, allowing up to 500 stretch. So up to, you'll be able to stretch to the maximum that you want without permanent disformation. So the molecular geometry or the stretch and recovery, that's the lycra or that's the spandex, helps in movement, in easy movement. You'll be able to run, you'll be able to do most of the things that you're supposed to do. So if you're an athlete, it's really important. You can't just wear any garments and just say you're just using it for a training. No, it's not possible. So the material science helps in the construction of the molecular geometry, that's the stretch and recovery. Now let's go to the bioengineering or the sustainability, that's the lab grown. Example is the Pinatex. Why the Pinatex? Under the material science, you are using, example is the Milo, that's the mycelium leather. So the mushroom roots are grown in a lab on sawdust. Why? Because it's a engineering and sustainability, that's lab grown, is mostly done in the lab. So for you to get this kind of Pinatex, you need a lot. So the mushrooms are grown in a lab on sawdust by controlling the humidity and the material and most of these. So the result is a leather-like sheet with a natural 3D microstructure which is breathable like plastic-based vegan leather. That's the PU. So the Pinatex, what is it made of? The Pinatex, that's an example of a what? Bioengineering and sustainability. That's a lab grown. So the Pinatex, that's a cellulose fiber mechanically is extracted from a pineapple what? Waste. Pineapple leaf, sorry. So that's the agricultural waste. Material scientists use a fabrication process to break the large bundles into small, interlocking the microfibers, which is often felt and coated with a bioresin to create a non-woven textiles that mimics animal hide. So the bioengineering and sustainability, that's the lab one, that Pinatex, is made up of agricultural waste. So they are able to generate a lot of lab grown to be able to get some of the garments that we want so that the athletes can wear them. So now let's go to the next one. That's the structural rigid or the sculptural fashion. Example is the neoprene in hook couture. So let's go to the next one. That's the structural rigidity and sculptural fashion. Example is the neoprene in hook couture. So under the material science, using gas expansion within polymers to create stiffness without internal bonding. So example is the neoprene in hook couture. So technically, um, microscopic gas bubbles is trapped inside a polymer matrix to give a thick, rigid cellular structure that holds dramatic architectural silhouettes like a 3D sleeve. So it creates an architectural silhouette like a 3D sleeve that stand up on their own yet remain lightweight. So the structural rigidity or the sculptural fashion. So the material culture helps in creating different kinds of lightweight designs to be able to come out with something extraordinary. So one thing about material culture is how does it interact with the environment on molecular levels. So it helps in the interaction by the driving force behind sustainability, smart wearables, and extreme performance sportswear. So mostly this is about these examples, the ones that I've just mentioned right now. This material science, right, is an example of the example of the sportswear that we see around or what people, the athletes wear. So this material science helps in constructing, developing, and finding new ways of coming out with a product. So it's really, really important that material science helps. So what are the key skills and qualifications needed to drive as a material science textile engineering, and why is it really important? Well, to thrive as a textile science engineer, you need a solid background in textile engineering, polymer science, and material characterization, often supported by a relevant engineering degree. So for you to be good with your material science, you need all these. So there are things that you need for you to understand, for you to know or to understand the material science with it. So there are certain softwares you must be relevant with it. the computer aided design, that's CAD, the STEM, the FTR, and the tensor testers. So, and also the knowledge of quality standard, that's the iOS, is typically required. So you also need a strong problem solving skills, creativity, and effective critique to excel in this innovative textile product. So these are the competencies that you need for the qualification for you to thrive as a material science textile engineering. So they are really, really important. And there are other ways, there are some challenges that material science professionals face when they are working on a product development teams. So a career, let's say an example, a career science textiles, right? So they often encounter challenges such as balancing innovative material properties with manufacturability and cost constraints. So these are the key problems that mostly they face. So one additional, they need a new textile product material meeting in that industry standards and sustainability goals that can add complexity to the development process. So effective communication and reproach, reactive approach to problem solving are essential to overcome these hurdles and delivering successful products. So there are some challenges that they face, but if you are able to get the effective communication, you'll be able to solve most of their problems. So what's the difference between material science textiles and material testing technician? Um, there are a lot that goes into it. So the material science textile professor focus development and improving textile materials, working in research and development design environments. So in contrast, material testing technicians primarily perform tests to ensure the material quality and compliance. So both roles require knowledge of material. They have daily tasks and industry application differ slightly. So these are what material scientists or material textile, um, there are differences between those two things. So what are the commonly challenges faced by this?